Welcome to Preface, a data-driven volumetric prior for few-shot ultra-high-resolution phase synthesis. Ultra-high-resolution novel view synthesis of faces in the sparse setting is a highly challenging problem in 3D computer vision. In this work, we propose a novel prior model over faces that can be fine-tuned to generate a high-quality volumetric 3D representation of a target identity from a very small number of input views. In this example, our model is fit to the 3 input images of a holdout identity on the right. On the left, we render novel views. Although the model has only seen 3 images of the target subject, it renders highly detailed novel views. State-of-the-art neural models for novel view synthesis, like NERF, achieve high-quality results in the dense setting when dozens or even hundreds of views are available. But most models struggle in the sparse setting. Even methods specialized for sparse input suffer when given only 2 views. How can we leverage prior knowledge to enable high-quality novel view synthesis from only 2 views? Our pipeline consists of 3 steps. First, we train a multi-subject prior model on a collection of low-resolution multi-view images. We then perform inversion and model fitting to render novel views at a high resolution. Training the prior model is a one-time event. The inversion and fine-tuning is performed for each target identity. Let's see the 3 steps in more detail. In the first step, we train a multi-subject prior model. The prior model is a conditional NERF trained on a collection of 1,500 multi-view face images of size 512 × 768 pixels with a neutral expression. The prior model learns a smooth representation over face geometry and appearance. The top right shows PCA samples from the latent space, and the bottom linear interpolations between reconstructed training identities. After training the prior model, we fine-tune it given sparse inputs. The first step is finding a good initialization by inversion. This step is crucial to avoid geometry artifacts. The inversion only optimizes the target latent code while keeping the model weights frozen. The output after inversion matches the overall geometry of the target subject, but lacks details. The details are added in the last step. All the previous steps used low-resolution images, but we want to perform novel view synthesis at much higher resolutions, up to 4K. The final step is fitting the full model on the high-resolution images. A naive optimization of all the model parameters would overfit in the view branch, highlighted in green. The effects are strong color jitter and a fuzzy surface that fakes specular reflections. We solve this with additional regularization terms. In the following, we demonstrate results after fitting to 3, 2, and 1 images. Here are 4K novel views after fitting to 3 images of an unseen identity. The orange inlines are the input images. Note that our prior model is trained on studio captures only, and it still generalizes to other datasets and in the wild. For this example, we captured 2 outdoor images with a mobile camera. The next subject is photographed in a room. To demonstrate the robustness of our method, we show an example on the Facescape dataset. Note that Facescape is not part of our training set. Here, we perform reconstruction under challenging lighting conditions. We close with one-shot synthesis results. The first 2 examples used a single image taken outdoors. The third image was downloaded from the internet, and the bottom example is an unseen subject from our studio dataset. Come and visit us at our poster at 10:30 on Wednesday in the session 3D from Multiview and Sensors. In the meantime, check out our project page and paper. Thank you.